Today, Dr. Satkumar sir will be speaking about leveraging satellite data for smarter soil organic carbon management. We are incredibly fortunate to have Dr. Satkumar sir to share his insights and expertise with us. Welcome you, sir.
Yeah, thank you. Thank you, Prakash sir, for inviting. See, what we are trying to do is, we cannot go, to each and every farm, every place and make the measurement. So my entire, career has been about how we can leverage limited, field data, take the satellite data and make the measurement over the large area. That's, what we are trying to do for agriculture for different parameters. So I'll just give a, brief of, what we can do. If you have any question, you can reach me at the end of the, you can ask the questions. You can reach me at the end of the seminar through my email ID, my phone number.
Yes, sir. Please proceed, sir.
Yeah. So just to give a brief of the company, before I start. So we started about 6 years back and we largely work for the agriculture, crop insurance and BFSI segment, So many of you might be aware of the satellite remote sensing. So briefly, what it means is like, let's say, for many health reason, we go to, we do remote sensing, like we do X-ray, we do CT scan, we do many things. So what happens in satellite remote sensing, each and every wavelength, they are, sensitive for something, there are some wavelength which are sensitive for water. There are some wavelength which are sensitive for the crop health. Some are, let's say for the nutrient. So we make use of those wavelengths and we estimate those properties using the satellite remote sensing data. So this is, how the satellite operates. 1 second. So these are the satellites, like, largely we make use of many satellites from NASA, from ESA, from ISRO, from Japan. So what we do is, through our web application, mobile application. So we need the geolocation of the farm. Either a farmer can walk around the farm or they can, locate on the Google Earth background. And then we download the satellite data. And then we have algorithm in the background to estimate various variables. I'll be focusing more on solving carbon representation. So that's how we deliver. It looks like, very long procedure, but in the background, we do a lot of work. So it takes hardly, few seconds to deliver the product to the farmer. So we provide the soil health report, which means we provide the 5 nutrients to the, to the farmers. So we provide soil organic carbon, pH value, NPK. So for each and every farm, just once, geolocate the farm, you start giving the data. And this data we have developed by using the about 20,000 sample across India. And we have, used about 60% for the calibration of the model, about 40% for the validation of the model. And based on the soil nutrient, parameters, depending upon the crop type, we tell to the farmers how much fertilizer they need to apply, which kind of fertilizer they need to apply, when they need to apply. So this is, how the report looks like to the farmer. They'll geolocate the farm. And apart from the soil nutrient, we also tell farmer many other things, which are impacting the soil organic carbon. Like we look at the alternating and wetting, drying. Typically, we try for the paddy farms, whether they are following the water ponding all the time or they are following alternate wetting and drying. All these kind of things we capture with the help of satellite data. We also capture whether they are following the conventional tillage or they are, doing less tillage so that, more organic carbon can be saved. We also capture whether in the, in between the crops, whether they are following the cover crop or there is, it's barren land all the time. So we can capture, how much organic carbon they are saving. We do SOC measurement before the season, after the season to see how much changes we are making. In this, you can see, it was 0.59 before the season. After season, it's 0.5. So we can see how much stock, they are conserving. Apart from the organic carbon, maybe not directly related to this presentation, but, we provide many other things to the farmer, like, the weather forecast, so that farmer can decide what are the best time for the certain, practice to follow, let's say sowing, harvesting, all those kind of things. We provide image-based advisory. Farmer can upload the image and they get the immediate, information on the what kind of pest or disease they are having, what is the best solution for that. We provide the best package of practice depending upon the agroecological region, which are the best package of practice they need to follow in the timely manner, what's the best time to do certain things, all those kind of things we provide to the farmer. We provide information on the irrigation water management. Typically, what we have seen is, in agriculture, you see, you need to irrigate, once in, let's say, December, January, all those kind of things. But here we take into account the soil moisture data. We take into account the next 15 days weather forecast data to compute the evapotranspiration, to compute, the how much rainfall may come. And based on that, we tell the farmer, this is the frequency you need to follow. This is the amount of irrigation you need to apply. So these are some of the soil moisture images you can see, red means very low and blue means very high soil moisture. So this is the kind of information we provide to the farmer. You can see here gross irrigation, in mm, how much they need to irrigate and the frequency of the irrigation. And this depends upon the weather forecast data, soil moisture data, and the, type of crop and the stage of the crop. We also provide the crop health data, that is like, NDVI. In very simple term, it's like, the how green a plant is. Like you can see here, a part of the farm is looking, yellow. It's a tree, so it might be impact of some other crop, but farmer can see what is happening in the farm. So if in the middle somewhere there's some issue, they can figure it out. But it's more like a, when the crop is there, how much moisture we have in the plant. This is summary of what we do. We provide, NPK, pH, SOC, crop health data, early warning for pest and disease, how much soil moisture we have, how much farmer need to irrigate, when they need to irrigate, and the weather forecast data. These are some of the pilots we have done. So we provide it through mobile app. We also provide API. Somebody can use in their mobile app. And we have a web platform where, you can see about the large number of farmers, what they're doing. So the process to use is very simple, they just need to register it in the application at the farm and they start getting the data. I'll just play a small video.
3 coordinate points to get the polygon of your farm. SAT2 Farm app, demo of adding the farm. Step 1. On the home screen, you can see the Add New option. Under this, choose any of the provided options. Step 2. Choose the farm option. If you are the first-time user, enable location access to the SAT2 Farm application. Step 3. There are 2 ways of adding your farm, either by walk or draw. Step 4. If you choose the draw option, enter the farm name, then tap Next button. Step 5. The red dot on the map shows your present location. Locate your farm and geotag the farm by pinning or marking the boundaries with at least 3 coordinate points to get the polygon of your farm. Step 6. You can delete the marking by simply selecting the undo.
This is summary of, what we do. All the parameters we provide, spatial resolution, temporal frequency. And this is the comparison of the soil moisture data, what kind of accuracy we get. So we make lots of measurement in the field and we get the data from satellite. We estimate from the satellite and we figure out how much accuracy we are getting. So in terms of soil moisture, typically we get RMS about 6 or 7%. This is the comparison for the nitrogen, the Zambia from Karnataka. We work in many countries, about 20 countries we are more active, in many countries in Africa, in Latin America, of course in India and in Southeast Asia. These are the some of the companies we are working with. So about 300 channel partner we have. Through them, we provide the service to the farmers. Yeah, thank you. Any question you have, please feel free to ask it. There are some comments in the chat. Is it for me or?
That's for you.
1 second. So I can see one comment. This satellite data you have used. See, it depends. We use for soil moisture Sentinel-1 and its map data. For the nutrient, we use Sentinel-2 data. For the crop health, we use Sentinel-2 data, Landsat-8 data, and the MODIS data. For soil moisture, we are using Sentinel-1 and this map data. We have taken about 20,000 samples across India, and we have used the Sentinel-2 data. So we use several bands of Sentinel-2 data, few bands for figuring out whether the land is barren or not. Once the land is barren, then we have used those bands for training the this machine learning algorithm for training our data. So we use several bands of Sentinel-2 data mainly for the estimation of SOC. Can satellite record the soil organic carbon? Yeah, we are doing that. We estimate soil organic carbon when the land is barren, not when crop is there. So we estimate before the season and after the season. We estimate how much organic carbon we have. Yeah, this app is available in about 18 languages. So we have most of the Indian languages, and there are some outside India, French, Arabic, Turkey, all those kind of languages are there. And you can try the app, through Sir or maybe through Rosna. You can let me know. You can try the app.
More questions are popping up, so could you please answer the same?
Yeah, so there is which data set for soil moisture can you suggest for Indian topography? No, see what happens. If you look at this map, it's very good data set. It's available approximately 9 kilometers, which is very coarse. So we use the same data and we use Sentinel-1 data, which is microwave data, to bring it to the farm scale. So there is no one data, which you can use. So you need to combine different data set and, you can work on it. SOC stock to what depth? It's about, you can say about 10 centimeters, which we have used for training our data. So it's mainly surface or, you can say near surface.
Sir, what is the resolution of the data which you have used for these things?
1 second, sir. So this is the resolution data. There are different data set. So you can see here, there are some at 10 meters, some at 20 meters, some at 20 meters also.
Sir, this MODIS data and Landsat data, they are all free satellite data, no, which you are using it for
Yes,
this study, sir. They are all free, and the resolutions are very, very, very low. I think they cannot be up to farm level. Can we predict it, sir?
Sir, if you look at not MODIS, it's used just for some purpose. If you look at most data is at 10 meter, 20 meter. So if you look at farm scale, typically a farm can be about 1 acre. So if we take 10 meter data, we are talking about 36 pixels in a farm, which is more than what is required.
Because at ISRO and National Remote Sensing Agency and all, they are using the quick bird iconos and other 1 meter resolutions data and all those things for farm level studies and all those things. Since we are going in depth in the soil studies, especially the nutrients and the carbon studies and all those things, sir. Is it? I am doubt about the parameters which we can analyze through these data.
So I didn't get the question. Your question is about the resolution or about the parameter what we can estimate?
No, the resolution of with respect to the topic of the leveraging the satellite data.
Yes,
because
sir.
When we are going for leveraging the satellite data, we have to go for higher resolution satellite data,
Take-
especially the quick birds and the iconos and other things, sir.
No, sir.
You have the resolutions of 1 meter capacity. I think that those can help in the in-depth study of the soil parameters, I
No,
think.
sir.
Otherwise,
No,
the MODIS and satellite data can give only
no, sir.
the
I did
upper,
not speak only
the
about Modi's.
surface
Hold on.
parameters and things, sir, I think.
Hold on, sir. So if you take
Yes,
10 meter data, in 1
Yes,
acre, we get 36 pixel, which
Yes,
is more
ah,
than
ah.
what is required.
Yes, sir.
Yeah. So I'm not talking only about Modis, we use lots of data. Modis is one of them.
MODIS is the base. Is it the base main data?
No,
Sir?
no. We use mainly Sentinel-1, Sentinel-2, and the SMAP
What
also
are
we use.
the
use
ancillary
landscape
data? What are the ancillary data you are using it for the
So
coordinating
we
the
use several data
satellite?
sets, we use weather forecast data, we use slope,
Any laboratories data you are using it? Soil laboratories data in the
for
countries?
calibrating the model, yes, we use the lab data.
Or
Use Sentinel-1
SCR
for
data
the
sort of things, sir. These things. If you use such data, then it will be more
we do use.
practicably applicable to the farm level, and we can give direct suggestions.
We do use. We do use, Sentinel-1 data for, and we have used lot of, field measurements for the training of our model, and testing of the model.
Because this is a good initiative, so because no farmer is going for especially the small, marginal, and medium farmers are not going for testing. Only the large farmers are going for the soil health testing. It will be especially the helpful for the small and marginal farmers in countries like India and others.
Yes.
Yes. Good, very good initiative. Thank you very much.
So I have a question. Can I ask it?
Please, sir, yeah.
So I wanted to get an idea about the cost involved. Say we are an organization working with 10,000 smallholder farmers, and we want to get their data. How does that work? What would be the cost
To the
involved?
farmer, we charge 750 rupees per acre per season. Season is 6 months for us. But when we work with somebody, there's a different pricing for that. Sir, you can note down my number. You can reach out to me and we can discuss the costing part.
Yeah, other questions, please, from any other participants.
Sir, there are some more questions which are important. Can you please explain regarding the pest and disease forewarning?
Yes, sir. So what we are doing is we look at the environmental condition in which a pest and disease can grow. So we look at the weather forecast data, temperature, relative humidity, rainfall, and then we tell farmer, this pest may come, this disease may come. That's how we provide the forewarning to the farmer. This is only a forewarning, not reality. It may happen or it may not happen.
Sir. Hello.
There is one more common question. What is the overall accuracy of the data?
Sir, for the this organic 1 second. If you look at the weather this nutrient parameters. 1 second. One second, sir. I'll just start the slide. Typically, it's about 85 to 95%. It depends upon the parameters.
Okay. One more, sir.
Yes, sir.
Can you give a brief idea about cost?
Sir, it's to the farmer, we charge 750 rupees per acre per season. But when we work with somebody, then we of course, we negotiate the price and we provide.
So what are all the components included with that 750 rupees?
So all the parameters, whatever I have mentioned.
Okay.
So I have shared my number in the the chat. You can drop me a message and we can connect and we can discuss later.
So for
I have
also the same type of costing is there, or there is somewhat
same
difference?
costing, sir. Costing is same for any crop.
Okay. Thank you.
Welcome, sir.
So I have another question. My name is Rajiv Barua.
Yes, sir.
I just wanted to ask you, have you validated the data? Okay, you're saying the accuracy is So 90% is the accuracy of soil organic carbon, is it?
Yes, sir.
Okay. And are you aware now with this, this huge carbon trading happening, and there are many voluntary standards like Vera Gold Standard, where people are actually offering carbon sequestration in the
Yes,
market.
sir.
Do you have any experience working with some of these voluntary agencies, and how does your model or the services that you offer align with them? Because those are global. For example, any of us who wants to get into the carbon, especially the sequestration market, would your data then be acceptable at the international level by these
Yes, sir.
standards?
So there are some procedure, we have worked with Vera. In the case of VCS, it's not like, sir, you are a certified agency. There are certain protocol we need to follow. We need to register a project, what we want to do in that project, what are kind of activities we are doing. So there are certain guidelines we need to follow, but we do that, yeah. So we work with companies for that purpose, sir.
Thank you, sir.
Welcome, sir.
Thank you for excellent summing up of the questions. Finally, I'd like to invite Dr. Divishri K to deliver the vote of thanks. Over to you, ma'am.
Good afternoon to all. On behalf of our Center of Excellence on Watershed Management, I would like to express our deepest gratitude to all who have made this webinar success. First and foremost, I would like to extend my sincere thanks to our esteemed Vice Chancellor, Dr. Suresh sir. Your leadership and vision have been a guiding force behind today's gathering, and we are truly grateful for your unwavering support. Our sincere thanks to our distinguished speaker, Dr. Satyukt sir. Your enlightening presentation has shed light on leveraging satellite data for smarter soil organic carbon management, providing us with invaluable insights. Your contribution has significantly enriched our understanding, and we are fortunate to have the opportunity to hear from you. A special note of gratitude to Mr. Mahesh B. Shirur, WDD Commissioner, for your presence and invaluable input. Your support and engagement in today's discussions have been immensely appreciated. And I would like to thank Dr. M.B. Prakasha, our special officer, whose dedication and hard work have been pivotal in organizing this event. Your effort behind this noticed, and we are truly thankful. Finally, a big thank to our consultant, Dr. Nagaraj sir, and for your expert guidance and assistance throughout the planning process. Your insights and advice have been crucial to the success of this event. To all our participants, thank you for your active involvement and enthusiasm. Your presence and contributions have made this event truly special. Once again, thank you all for your support and participation. We look forward to more such informative and engaging webinars in the future. Thank you.
Thank you, Dr. Divishri, and thank you everyone for your active participation in today's webinar. Thank you, sir.
Thank you.